Today in this video, you guys are going to learn about formulas in geometry. Our learning goal is to apply those formulas to calculate different measures. And the specific success criteria that you have for this is to be able to identify the base and the height in a figure, specifically a triangle. You also need to be able to use a formula to calculate the perimeter of a square, rectangle, and a triangle, and use a formula to calculate the area of a square, rectangle, and triangle, and then also to be able to find the circumference and area of a circle. So in the notes today, we're just going to go over some of the basic definitions and formulas, and then we'll work the examples in class. So let's start with area and perimeter. Okay. The perimeter of a figure is just the total lengths of all of its sides. In other words, you just add up all of the sides. Now when we talk about this figure here, that figure has to be what we call a plane figure. In other words, it has to be flat. So when I say the perimeter of a figure, I'm really talking about the perimeter of a flat figure. The area of a figure, and again, this is still a plane figure, a flat figure, is the number of square units that exactly cover the figure. So if my figure was something like a rectangle, it's pretty easy to calculate because I'm just going to divide my rectangle up into individual little squares like this, and I'm just going to count how many squares fill the entire rectangle. So we can have 2 squares going up and down, 5 squares going across, 10 squares cover the rectangle. I don't know how big those squares are. They're 1 unit by 1 unit maybe. So I would say the area is 10 square units. So now let's talk about the formulas for these things. For a rectangle has often what we call length and then width. So the perimeter of that rectangle is 2 times the length plus 2 times the width. Right? I have 2 lengths, and I have 2 widths. So I'm just going to add those together. Length plus width equals 2 lengths plus 2 widths. The area, on the other hand, is the length times the width. That's going to give me how many square units cover that surface. Always make sure you're thinking about units when you're talking about perimeter and area. If you're talking about perimeter, my units might be in something like inches, just a length, but my area would be in something like inches squared, because I want to know how many little square inches that are inch by inch cover the surface. In a square, all of the sides are the same, so the perimeter is what we would get when we just add up each of these 4 sides. So side plus side plus side plus side is 4 sides, so that's 4s. So here my s is representing the length of one of the sides of my square. And then the area, of course, is just going to be, again, the length times the width, but since they're both the same, its area would just be s squared. Triangle is a little bit more complex. So here we have a triangle whose sides are A, B, and C. The perimeter then, of course, is just the sum of those sides, A plus B plus C. The area, however, is slightly different. Here we have what we call the base of the triangle, and then the height comes down and is perpendicular to the base. In other words, it forms this right angle that you see here. And the area formula for a triangle is 1/2 times the base times the height. Another way we can calculate that same thing is to take the base times the height and divide by 2. I want to talk a little bit more about the pieces of this triangle because identifying the base and the height is one of our success criteria, and it's extremely important when calculating the area of triangles. So let's focus in just on this section for a minute. So if you look at this picture, you don't have to draw this again. That's already drawn in your notes, or it ought to be. But do draw these other 3 pictures as we go through the notes. So in a triangle, the base can be any side of the triangle. In this picture here, the base was given to us as the bottom of the sorry, the base is given to us as the bottom of the triangle, so the base is there. The height is a segment that goes from the vertex that forms a right angle with the base. So it has to be the vertex that's across from the base. And not only that, we have to see that this is a right angle. I should put this in a different pen here. This has to be a right angle that's made with the base, just like that. And then this guy here would be the height. So we'll put that in red. We'll just do H for height because that's pretty standard. Comes down and is perpendicular. Now, I want you to draw two other triangles and examples of bases and heights because the base can be any side of the triangle like we just talked about right here. A lot of times we think of the base as being on the bottom, but it doesn't have to be. In this triangle it was, but in these two triangles it is not. So if we look at this triangle right here, I've set it up in this case so that the base is over on this side. Whoops, I don't want that over there. I want that right here. The base is here. And then if I draw this segment that goes from the opposite vertex so that it forms a right angle with the base, this guy is my height. So label that in there. If I take that very same triangle and I look at a different side, this particular triangle is kind of special. It's a right triangle because it has a right angle right here. So in this example, if I say that the base is this side on the left over here, then its height is actually going to be one of the sides of the triangle. It extends from the vertex that's opposite of the base, and it forms a right angle with the triangle. So that can happen when you have a right triangle. Alright, so now that we've discussed triangles, bases, heights, area, and perimeter of plane figures, let's move on to the other topic that we have to discuss, which is formulas for circles. So again, with circles there's quite a bit of vocabulary, so let's break this down into some smaller parts here. First of all, the circle itself is all of the points that are exactly the same distance away from this one point, which we call the center. So once we've created that circle, and you guys are all familiar with what circles look like, we say the diameter of a circle passes through the center and it has both endpoints on the circle. So in other words, it's got to start over here, it's got to end over here on the circle, but it's got to go through the middle of the circle. It's got to go through that center piece. In addition to the diameter, we also have what's called the radius. And then the radius is like the diameter. It begins at the center, except for it only extends to one side of the circle. So it only has one endpoint on the circle. Begins at the center and has one endpoint on the circle. And of course, 2 radii equal 1 diameter. You can see we have a radius here, a radius here, and together they form a whole diameter. So 2 radii equal 1 diameter. Alright, my next vocabulary word is circumference, and this is one of the things that we need to be able to calculate for this section. And the circumference is the distance around the edge of a circle. It's kind of like perimeter. So if I was walking on a giant hamster wheel around the outside of it or something, how far I walked would represent the perimeter of that hamster wheel. So you can kind of visualize, oh, it's going to do this weird thing. You can kind of visualize if I put my circle down on this line and I rolled it out to the other exact point where I started from, how long that line would be. Visualize it like a roll of toilet paper, right? If you roll out a roll of toilet paper, you get like a little flat line of toilet paper that you could wrap around the edge of the roll. The distance that that piece is that you would wrap around the whole edge is the circumference. And then of course the area is just the space inside the circle. In this case, we can't really fill it up with exact square units, right? My little squares are getting cut off by this curved part of the circle, so it's harder to count, but we're going to use a formula to help us calculate the area of the triangle. Alright, so the formulas that we're going to use for a circle are given to us by the circumference, which we represent using c. So the circumference c of a circle is given by the formula c equals pi times d, or c equals 2 pi times r, or 2 pi r. Now pi, remember, is this special ratio. We'll talk more about where it comes from in class, I think, tomorrow. But it's a special ratio, and we can approximate it with the value 3.14, or we can use a more exact, well, it's not more exact, but we can use a better approximation using a calculator with the pi button. So then the area of a circle is represented, of course, by A, and it's given by the formula A is equal to pi r squared. Now you absolutely should know these formulas. These are two formulas that you should just know, so practice studying them and memorizing them if you don't already know them. You also have to know the difference between which is which. So you have to know that 2 pi r is for circumference and pi r squared is for area, and they're pretty close to one another, so you want to make sure that you're not mixing those two up. Okay, so this is it for the notes that we're going to take here. We got all the vocabulary and formulas down, and then we'll work the examples in class.